Hi everyone, so this is the second video on nomenclature for writing formulas for ionic compounds. So reminder that ionic compounds are compounds that have metal bonded with a non-metal, right? For which the metal might be single or multivalent. The non-metal could be a regular non-metal or a polyatomic ion. Oops. Hi everyone, so this is the second video for nomenclature for writing formulas for ionic compounds. So reminder that an ionic compound is a compound that has a metal, except for ammonium, which behaves like a metal, bonded with a non-metal. Okay, so a metal could be an ammonium ion, which behaves like a metal, or a multivalent metal, or a single valent metal. Your non-metal could be a regular non-metal or a polyatomic ion. So remember that regular non-metals end with "ide," and then your polyatomic ions end with "ate" or "ite," with the exception of a hydroxide, which does end in "ide," but it's also polyatomic. Okay, so let's try some examples. Our first example is potassium nitrate. Okay, so again, just like writing formula, I usually look at the metal first and then the non-metal. Okay, so potassium here, they didn't give you a bracket, so that means that it's single valent. Okay, so potassium is right here, and we remembered all the charges, so +1, +2, and so on, but this is a +1 metal. So we can write down potassium, which is a +1. Okay. For the non-metal, the first thing I notice is that it ends in "ate," which is a signal or hint that tells you that it's a polyatomic ion. Right? Nitrate, it's right here, nitrate. So it's NO3 with a -1 charge. So we're going to write down NO3 with a -1 charge. So now we are ready to crisscross. Once we have both metals and non-metals written down with the charges, we are ready to crisscross. So the 1 goes here, invisible. The 1 also goes there, also invisible. Right? And remember, a reminder that we don't carry the negative and the positive sign, so just a 1 and 1. So our final answer would be K1 invisible, NO3, with also a 1 that's invisible. Okay. Also, I noticed in your homework that a lot of you have written a space between the K and the NO3. That is not acceptable. So you get it wrong if you write a space between. Next example, sodium sulfide. Okay, so again, metals, sodium. Sodium is right here. It's one of our alkali metals, so it's a +1 charge. So we can write down Na +1. Okay, done with the metal. Looking at our non-metal, we notice that it ends with "ide." It ends with "ide." So it's just a regular non-metal, okay, not a polyatomic ion. And if you look at sulfide, sulfide comes from sulfur after it changed its name. Sulfur is right here, sulfide. So from remembering those charges, it's a -1, -2, so we have S with a -2 charge. Okay. Now we're ready to crisscross. 2 and 1 over on this side. So our final answer would be Na2S. Again, no space. And an invisible 1. Alright? Another example. Calcium hydroxide. Right. So a lot of you at this point might be getting really familiar with the polyatomic ions and the metals, and you might know from just remembering that calcium is an ion with a +2 charge. So we can write calcium +2. Hydroxide is special because it ends with "ide", but it is a polyatomic ion. So if you try to look for hydroxide on the periodic table, you would not find it. Okay, it is a polyatomic ion, so you do have to look in this chart right here. Hydroxide right here, OH with a -1 charge. So we're going to go back and write down OH with a -1 charge. Now we are ready to crisscross. We have written down both our metal and our nonmetal with the charges so we can crisscross. The one will go here with the calcium, is invisible. The 2 will go on the hydroxide. Okay, so we have a new rule here. What happens if you have a polyatomic ion and you have a subscript? Well, you cannot just write this. So a lot of people make the mistakes of writing calcium 1 invisible and then OH 2. You can't do that because what that means is that you have 1 calcium, you have 1 oxygen, and 2 hydrogens, which is not right. Okay? Because what you want to do is you want to have OH behaving like a group. So this 2, it's kind of like math. This 2 actually applies to both the hydrogen and the oxygen. Okay, and the oxygen. So really we have 2 oxygens and 2 hydrogens. Okay, that's what this 2 means. So how are we going to do that? Anytime you have a polyatomic ion with a subscript that comes from crisscrossing, you need to put a bracket around it. Okay, so anytime you have a polyatomic ion that has a subscript, that comes from crisscrossing, you need to put a bracket around the polyatomic ion. Okay, this subscript comes from crisscrossing with the calcium plus 2 charge. It didn't belong to the polyatomic ion before. It comes from crisscrossing, so we need to put a bracket around the hydroxide ion. Okay, so that's one of the new things that we have for writing formulas that involves polyatomic ion. Let's try another example. Gold 3 nitrite. So we have a bunch of things going on here. We have gold 3, which means that it's multivalent. Okay. We have nitrite, which means that it's polyatomic. So when you're doing your homework, you certainly don't need to write its descriptions down. It's just that you need to know that in your head so that you can get the right charges and get the right ions. So gold 3. If you remember gold symbol, it's a little weird. It's actually Au, and it comes in 2 charges, +1 and +3. Okay. So the gold 3 just tells you that you're using Au plus 3. The nitrite's polyatomic. Let's go to the polyatomic chart. Nitrite right here, NO2 with a negative charge. So we're gonna write NO2 with a negative charge. Now that we've written both symbols and the charges, we can crisscross. So -1 goes here, invisible. The 3 goes there. So again, we have this new subscript for our polyatomic ion that comes from crisscrossing, right? So that means we're going to have to write Au with the 1, and then NO2. The 3 comes from crisscrossing. Okay, now this is not correct yet. If you notice, this actually looks like Au, N, O, and then 23, right? So that's another reason we need a bracket. Okay, So again, anytime you have a subscript that comes from crisscrossing for a polyatomic ion, you need to put a bracket around the polyatomic ion. Okay? And when you actually go and count the atoms, so we're done writing formula. This is our answer. Okay, that's our answer. But if you are required to count the atoms, this is actually how it works. You have one gold atom. Okay, the 3, like math, carries into your bracket. So you actually have 3 nitrogen atoms. And then you have 3 times 2, 6 oxygen atoms. So that's how it works. Our last example is ammonium phosphate. Okay, ammonium, remember from my last video, is special. You will not find it on the periodic table. It's not a metal. It behaves like a metal. So ammonium is right here. It's our NH4+. Okay, so anytime you look at ammonium, you're going to have to remember to look at the chart. So we're going to write down NH4+. Phosphate, 8. 8. That's certainly polyatomic. So we're going to look at the chart again. It's our phosphate is PO4, 3 minus charge. So let's write down PO4 with a 3 negative charge. Now that we have written down both symbols and charges, we can crisscross. So the 3 goes here, 3, and the 1 goes there. Okay, it's invisible. So our final answer would be NH4, NH4, 3. Okay, see that the subscript that we added from crisscrossing, that means we need a bracket. And then PO4, 1. Okay, because the 1 is invisible, we don't write the number down. We don't need a bracket. Alright, so that's it. Now you guys are ready to do your homework.